Our universe is an endless ocean of unanswered questions. Drifting through this cosmic sea is a truly peculiar sight, the Tadpole Galaxy, a stunning pinwheel of stars with a bizarre, flowing tail stretching across space. Within its strange anatomy lie secrets that defy everything we think we know. This journey will reveal 30 of its most baffling inhabitants, from invisible matter clumps to stars that should not exist. You will discover cosmic phenomena so strange they rewrite the rules of physics. How can a cloud of gas heavier than 1,000 suns simply refuse to create new stars? What mysterious force is flinging entire star clusters out into the void? Which of these 30 cosmic oddities will truly make you question the nature of reality itself? At the very heart of this cosmic tadpole lies an engine of profound power and mystery. Its core is what astronomers call an active galactic nucleus, a term for a supermassive black hole that is actively feeding on the material around it. But this is no ordinary monster. The energy pouring from the tadpole's center is strangely subdued, a quiet murmur compared to the cosmic screams of quasars. Those brilliant beacons are black holes feasting on immense amounts of gas, shining with the light of 1 trillion suns. Our tadpole, by contrast, seems to be on a cosmic diet. Its emissions suggest it might be classified as a LINER, which stands for Low Ionization Nuclear Emission Line Region. In simpler terms, the gases at its core are only weakly energized, glowing faintly rather than blazing. This paints a picture of a galaxy in a more mature, settled state. Its central black hole is not ripping entire stars apart in a frenzied feast, but perhaps sipping slowly on a thin trickle of interstellar gas. This gentle activity is a vital clue, telling us we are looking at a galactic elder, one that has largely exhausted the vibrant, chaotic fuel of its youth. Yet this quiet, mature heart hides violent echoes in its past. Drifting away from the tadpole's main body is a prodigal sun, a massive globular cluster on a one-way trip into the abyss. This is no ordinary group of stars. It is a city of ancient suns, millions of them, packed into a sphere so dense that if you stood on a planet inside it, the night sky would be a perpetual brilliant dawn. But this glittering metropolis is in revolt, moving with such immense speed that it seems to be escaping the galaxy's gravitational pull entirely. Its velocity is all wrong, a cosmic anomaly that defies the gentle hold of the tadpole. How does something so massive, a collective weight of stars far greater than our entire solar system, achieve such a spectacular escape? The most compelling theory points to a galactic near-miss. Billions of years ago, another galaxy may have swung too close to the tadpole. In that gravitational dance, the invisible forces would have slingshotted this entire star cluster, flinging it away like a stone from a catapult. It is a permanent exile, a relic of a past collision that continues its lonely journey through the dark. While the exiled star cluster flees its home, another ghost haunts the tadpole's long tail. Drifting in the emptiness between galaxies is a colossal, shapeless cloud of pristine hydrogen gas. This is not a nebula glowing with stellar light. It is a cold, dark island of raw material, detected only by the faint radio whispers it emits into the void. Its sheer scale is almost incomprehensible, containing enough mass to forge over 1,000 stars the size of our own sun. Yet this vast reservoir of potential remains eerily silent and dark. It is a cosmic paradox, a stellar nursery that has stubbornly refused to give birth. For a new star to ignite, a cloud of gas must collapse under its own gravity, growing dense and hot enough to spark nuclear fusion at its core. This ghostly cloud, however, seems to be caught in a state of perpetual stillness. What cosmic force is keeping it asleep? The answer may lie in its profound isolation. Without the shockwaves from nearby supernova explosions or the gravitational nudges from passing stars, the cloud may simply lack the trigger it needs to begin its great collapse. It is a monument to potential, a frozen future adrift in the dark, challenging our very understanding of what it takes to light a fire in the cosmos. But the silent cloud is not the only paradox hiding in the tale. Far beyond its dark expanse, astronomers have spotted a flicker of light that reveals something even more perplexing. A world where the rules of planet building seem to have been broken. This is the story of an impossible planet candidate. It was not found by a telescope seeing it directly, but by a cosmic trick of gravity called microlensing. When a massive object, like a star with a planet, passes in front of a more distant star, its gravity acts like a lens, bending and magnifying the background star's light for a brief period. By studying that brightening, scientists can deduce the properties of the foreground object. The data from this event painted a bizarre picture. The suspected planet is colossal, many times more massive than Jupiter. But its location is the true mystery. It orbits its parent star at a staggering distance, a gap so vast it defies our current models of how giant planets form. We believe gas giants are born close to their stars, within the dense, swirling disk of primordial gas and dust, or far out through the slow clumping of icy material. This object fits neither story. It is too heavy to have formed so far from its star through the core accretion model, and its existence challenges the gravitational instability model. It is a cosmic rebel, a planetary giant in a place where no planetary giant should logically be. The mystery of the distant giant planet is rivaled only by a signal from the void. Deep within the tadpole's sprawling tail, astronomers have detected a source of fast radio bursts. These are not gentle whispers of radio static. They are the universe's most powerful and enigmatic explosions of energy, blasting out more power in a single millisecond than our sun emits in 3 entire days. For years, these signals were cosmic phantoms, appearing once from a random point in the sky and then vanishing forever, leaving behind only confusion. But the source in the Tadpole Galaxy is different. It repeats. It crackles back to life again and again, sending its impossibly bright pulse across the cosmos on a schedule that seems to have no pattern at all. This repetition is the single biggest clue scientists have ever had. It rules out catastrophic, one-time events like the violent death of a star or the collision of 2 black holes. Instead, the culprit must be an object that can survive these immense outbursts and power them over and over. The frantic search has narrowed to a few terrifying possibilities. Could it be a magnetar, a type of neutron star with a magnetic field so powerful it can literally twist the fabric of space-time, causing starquakes that rip through its crust and unleash these bursts? Or is it something interacting with a supermassive black hole, where immense gravitational forces are tearing apart entire asteroids and converting their mass into pure energy? The repeating signal from the tadpole is a siren call, a persistent message from an object whose very nature defies our current understanding of physics. These repeating radio bursts are not the only invisible force at work in the tadpole's tail. Something else is out there, a ghost in the cosmic machinery that we can only see by its shadow. Astronomers mapping the faint light of galaxies far beyond the tadpole noticed a strange distortion. Their images were being stretched and warped, as if seen through a giant, invisible magnifying glass. This phenomenon is called gravitational lensing, where the gravity of a massive object bends the very fabric of space, curving the path of light that travels through it. The cause here was not a visible galaxy or a cluster of stars. The lensing effect revealed a massive, dense clump of pure gravity, an isolated knot of dark matter drifting through the tidal stream. Its calculated mass is staggering, yet it emits no light and contains no stars we can detect. This presents a profound challenge to our understanding of the dark universe. Most models suggest dark matter forms a smooth, enormous halo around a galaxy, not dense, isolated chunks in its tail. Finding this clump is like discovering that the invisible glue holding the universe together can also ball up into tight, massive knots, wandering alone in the darkness. Its very existence forces us to reconsider what dark matter truly is and how it behaves on the grandest of scales. Even the most cataclysmic events in the cosmos can be deceiving. Nestled within the tadpole's spiral arm is the record of a stellar explosion that refused to follow the rules. Astronomers initially catalogued it as a standard supernova, the final, brilliant death scream of a massive star. But this one did not simply blaze and fade into obscurity. Its light curve, the graph of its brightness over time, became a roller coaster. It faded, then surged back to life, not just once but multiple times over many months. This was no ordinary death, it was a stellar performance, an imposter mimicking a supernova's grand finale without the finality. So what cosmic actor could stage such a show? The prime suspect is a class of star known as a luminous blue variable. These are titanic, unstable suns, hundreds of times more massive than our own, that undergo violent convulsions long before their actual demise. They can shed entire solar systems worth of mass in gigantic eruptions, puffing out vast shells of gas. The tadpole's imposter could have been such a star, experiencing a series of these eruptions. Each time it threw off a shell, the ejected material would expand and cool, causing the light to fade. Then, when a new, even more violent eruption slammed into that previously ejected shell, the resulting collision would create a new fireball, making the star appear to re-brighten spectacularly. Another compelling theory involves a dance of stellar doom within a massive binary system. Imagine two giant stars locked in a tight orbit. One begins to swell in its old age, transferring its outer layers onto its companion. This messy process can trigger enormous thermonuclear explosions on the receiving star's surface, or cause the entire system to be engulfed in a common envelope of gas, leading to repeated outbursts as they struggle to survive. The perplexing light curve is a direct challenge, a cosmic whodunit written in flickering light, forcing us to question if we are witnessing a star's final act or merely a dramatic, violent episode in its long and turbulent life. This cosmic theater of stellar imposters and dark matter phantoms is rivaled only by the sheer, tangible wealth hiding within the tadpole. Orbiting a young star in one of its distant arms is a treasure trove that defies all expectations, an asteroid belt gleaming with a concentration of metals so pure it could rewrite the value of entire worlds. Astronomers did not see this glittering ring directly. Instead, they analyzed its starlight using spectroscopy, a technique that breaks light into a rainbow of colors. When the light from the parent star passed through this belt of orbiting debris, specific colors were absorbed, leaving behind dark fingerprint lines in the spectrum. These lines told a startling story. They revealed the chemical signature of elements that are incredibly rare in our own solar system. A staggering overabundance of heavy, precious metals like platinum, gold, and iridium. In our local asteroid belt, these elements are scattered and diluted among rock and ice. Here, they appear to be the primary ingredients. Such a dense metallic belt could not have formed through the normal, gentle process of cosmic dust clumping together. Its existence points to a far more violent origin, the catastrophic demolition of a fully formed protoplanet. Early in this star system's life, a young world, perhaps the size of Mercury or even Mars, was likely shattered in a colossal collision with another massive object. The titanic impact would have vaporized the rocky outer crust and mantle, leaving behind only the densest, most resilient core material. This is the ghost of a planet, its metallic heart now scattered into billions of fragments, circling its sun as a permanent memorial to its violent demise. The implications are staggering for the future of this system. Any rocky planets that do form here will be seeded with an incredible wealth of these rare elements, potentially creating worlds with golden mountains and platinum-rich soil. For a spacefaring civilization, this belt would represent the ultimate mother lode, a single resource depot containing more precious metal than has ever been mined on Earth. It is a stark reminder that the cosmos is not just a place of mystery, but also of almost unimaginable material fortune, where the shattered remains of one world could one day become the building blocks of another. Yet the tadpole's quiet heart may be a cosmic illusion hiding a dance of unimaginable violence. The very center of this galaxy appears to be home not to one, but two supermassive black holes locked in a gravitational embrace. We cannot see them directly, but we can feel their presence through the ripples they create in the fabric of space-time. The most compelling evidence comes from a faint, rhythmic signal buried in the data, a signature of gravitational waves. These are not waves of light or sound, but literal distortions in reality itself, generated as these two colossal objects spiral around one another. Their orbital dance also betrays itself through a periodic flicker in the galaxy's brightness. As they circle, they stir up the maelstrom of hot gas and dust around them, causing the core to brighten and dim in a predictable, repeating cycle. This celestial tango is a slow one, with each orbit taking thousands of years. But it is a dance with a definite and spectacular end. The two black holes are destined to merge, slowly losing energy with every rotation as they radiate gravitational waves, drawing them ever closer. In the final moments before their collision, they will whip around each other at a significant fraction of the speed of light, shaking the universe with gravitational waves more powerful than the combined light of every star in the observable cosmos. That final merger will be a singular event, a storm in space-time that will forever alter the core of the Tadpole Galaxy, leaving behind a single, even more massive black hole. This binary system is a ticking clock, a countdown to one of the most energetic events possible since the Big Bang itself. Yet far from the violent core, a different kind of miracle illuminates the darkness. Adrift in the loneliest part of the tadpole's tail, a brilliant blue-white jewel blazes against the void. This is an intergalactic star-forming region, a cosmic orphan that has no business existing. It is a vast, luminous cloud of gas, a stellar nursery shining with the fierce light of newborn stars, but it is completely unmoored from the main body of the galaxy. Conventional wisdom tells us that to forge new stars, you need the deep gravitational well of a galactic core. This immense pull gathers vast clouds of gas, compressing them until they collapse and ignite. This orphan nebula, however, has defied that logic. It is a thriving metropolis of stellar birth built in the middle of a cosmic desert. So how did this happen? The answer is written in the violence that created the tale itself. When the Tadpole Galaxy had its ancient encounter, the gravitational tides did not just stretch stars into a stream, they also wrenched colossal amounts of hydrogen gas out into the deep. Within that ejected river of gas, local pockets of material became so dense and turbulent that they began to collapse under their own weight. The very forces of destruction, the same gravitational chaos that exiled star clusters, also provided the immense pressure needed to trigger creation. This isolated nebula is a testament to the universe's resilience, proving that even in the most desolate and unexpected places, the fundamental recipe for star formation can still unfold. It is a beacon of life born from a cataclysm, a vibrant pocket of order that emerged from pure chaos. Even the most perfect cosmic illusions can reveal profound truths. Drifting within the vast expanse surrounding the Tadpole Galaxy is a celestial halo of fire, a perfect circle of light known as an Einstein ring. This stunning phenomenon is not a physical structure, but a trick of gravity on a cosmic scale. At its heart lies a brilliant, distant quasar, a beacon of unimaginable power from the early universe. Between it and us lies a massive cluster of galaxies, a foreground congregation of stars and dark matter whose collective gravity is so immense it warps the fabric of space around it. This warped space acts like a giant, curved lens, bending the quasar's light as it travels toward us. When the alignment is just right, this lensing effect smears the quasar's single point of light into a complete or nearly complete circle. It is a cosmic mirage, a perfect echo of a single brilliant object seen from billions of light years away. But this beautiful illusion is far more than a curiosity. For astronomers, an Einstein ring is a precision tool for weighing the invisible. By meticulously measuring the ring's exact size and brightness, scientists can calculate the total mass of the galaxy cluster causing the lensing. They can then subtract the mass of all the stars and gas they can actually see. The remainder, often the vast majority of the total, is the mass of the dark matter halo enveloping the cluster. This allows them to map its distribution with incredible accuracy, revealing how this mysterious substance is sculpted into a vast, invisible framework that holds the entire cosmic structure together. The Ring of Fire is therefore a ghost image, a luminous signature that lets us see the shape and heft of the universe's own hidden skeleton. The ghostly ring of dark matter is not the only solitary traveler in the tadpole's tale. One of its most dramatic exiles is a brilliant blue-white beacon, a massive star hurtling through the void at an unimaginable speed. This is no leisurely drift through space. This is a full-blown escape, a runaway on a trajectory that will inevitably fling it out of the galaxy entirely. Its velocity is so immense it defies the tadpole's gravitational grasp, destined to become a permanent wanderer in the cold, intergalactic darkness. How does a star achieve such a spectacular exit? The most likely explanation is a cosmic slingshot of unimaginable violence. One compelling theory points to a supernova kick. Imagine this star was once part of a binary system orbiting a companion. When that companion reached the end of its life, it did not go quietly. It exploded in a supernova so asymmetrical that the detonation itself acted like a cosmic cannon, violently ejecting the surviving star. The sudden loss of the companion's gravity then released it like a stone from a sling, sending it careening across space at its current incredible speed. Another possibility lies in the chaotic dance of a dense star cluster. In such a crowded stellar city, gravitational encounters between stars are common. A close pass between a binary star system and a much more massive object, like the supermassive black hole at the galaxy's heart, could have acted as a gravitational catapult. One star from the pair could have been captured while the other was flung away at hypervelocity, a celestial billiard ball sent flying from the table. This lone, brilliant runner is a testament to the immense forces that shape galactic evolution, a permanent refugee from some ancient, catastrophic event whose light now streaks through the emptiness as a reminder of its violent birth. This silent gravitational anchor may be a ghost of a different kind. Deep within the tidal tail, a patch of space exerts a clear gravitational pull on the luminous matter around it, yet it emits almost no light of its own. This is a candidate for one of the universe's most elusive concepts, a dark galaxy. Imagine an entire island universe with the mass and structure of a dwarf galaxy like the small Magellanic Cloud, but built almost entirely from the invisible scaffolding of dark matter. It would possess the gravity to hold itself together, perhaps even to gather a wisp of hydrogen gas, but it would have failed utterly at the one thing we expect galaxies to do: create stars. The search for its faint stellar population is a monumental challenge. Astronomers use the most sensitive telescopes ever built, peering into that darkness to detect the faintest possible glimmers. They are not looking for bright, young stars, but for the ancient, dim embers of a failed creation, old red dwarfs or the ghostly glow of retired stars. Finding even a handful of these ancient suns would be a monumental discovery, confirming that this is indeed a dark galaxy, a place where the cosmic recipe for building a universe went strangely, silently wrong. Its existence would force us to ask a profound question. Is this dark galaxy a cosmic anomaly, a lonely failure, or is it the rule? Could the universe be teeming with such dark islands, outnumbering the glittering galaxies we see, making our familiar, star-filled night sky the true exception? Even the darkness can betray a secret. Within the tadpole's tail, a single point of light blazes with invisible fire, a beacon seen only by telescopes that peer into the infrared spectrum. This is no ordinary star. It is an unidentified infrared object, a cosmic paradox that glows with the heat of a billion suns yet remains utterly dark to our optical and radio eyes. It is a ghost in the machine of the universe, a source of immense energy that somehow conceals its true face. So what could possibly produce such a prodigious amount of infrared light while hiding every other trace of its existence? One compelling theory suggests we are looking at a superstar cluster in its cosmic infancy, a stellar metropolis still trapped within its own thick, dark cocoon. Imagine a vast, dense cloud of gas and dust, so thick that not a single photon of visible light can escape. Deep inside, thousands of massive stars ignite at once, blazing with ferocious intensity. Their fierce radiation, however, is immediately absorbed by the surrounding dust, which heats up until it glows with a dull, red heat, radiating all that captured energy back out into space as infrared light. We are witnessing the birth scream of an entire generation of stars, muffled by the very blanket that nurtured them. Another, even more dramatic possibility is that we are catching the earliest, most intimate stages of a galactic merger. This brilliant point of light could be the searingly bright nucleus of a tiny dwarf galaxy being consumed by the tadpole's tail. As this smaller galaxy plunges through the tidal stream, its own interstellar dust is violently shocked and compressed, igniting a firestorm of new star formation while simultaneously cloaking the entire cataclysm in an opaque shroud. The object's intense infrared signature would be the thermal echo of this entire galactic collision, a muffled roar of creation and destruction happening behind a cosmic curtain. This single point of invisible light forces us to confront the limits of our perception, reminding us that the most violent and energetic events in the universe can often be the ones most effectively hidden from view. The Tadpole Galaxy itself has become a vast cosmic screen, projecting the ghost of an event that occurred billions of years ago. Far beyond its spiral arms, a brilliant quasar, the active heart of a distant galaxy, erupts in a titanic flash of light. This initial pulse of radiation travels for eons through the void, but when it reaches the tadpole, it does not simply pass through. Instead, it illuminates a series of immense, dark dust clouds drifting within the galaxy's own structure. These clouds act like galactic movie screens, reflecting the quasar's ancient flash back toward us. The result is a celestial illusion known as a light echo. We do not see the original flash itself, but rather its delayed reflection, a faint, expanding ring of light that appears to move outward from a central point long after the initial event is over. It is akin to seeing the flash of a distant firework, and then, seconds later, watching as that light sequentially illuminates a series of closer, unseen smoke clouds, creating a slow-motion ripple of illumination. For astronomers, these echoes are not mere phantoms, they are precision tools for cosmic cartography. By meticulously tracking the expansion and brightness of the echoing rings, scientists can perform a kind of three-dimensional ultrasound of the tadpole. They can measure the exact distances to these intervening dust clouds, mapping their positions and structures throughout the depth of the galaxy. Each echo is a timestamp, a frozen moment that reveals the location and density of the cosmic dust that would otherwise remain invisible. This allows researchers to reconstruct the three-dimensional architecture of the tadpole's interstellar medium, uncovering vast lanes and turbulent pockets of material that tell the story of its past star formation and the violent gravitational tides that shaped its long tail. The ghostly echo is a direct probe into the galaxy's hidden anatomy, a reflection from the past that illuminates the present structure. Drifting alone in the profound cold between stars is a world without a sun. This rogue planetary mass object is a solitary wanderer, a dark sphere detected only by the faint, lingering warmth it radiates into the void. It is completely untethered, bound to no star, circling the galactic core on its own lonely path. The debate over its true nature is a fundamental question of cosmic identity. Is this object a brown dwarf, a failed star that never accumulated enough mass to ignite the stable nuclear fires in its core? These stellar underachievers form just like stars from the direct collapse of a gas cloud, but they simply lack the necessary heft. Or is this instead a true planet, a giant world like Jupiter, that suffered a catastrophic exile from its home solar system? The gravitational chaos of a passing star or a violent reshuffling of planets in its youth could have flung it out into the galactic darkness. The key to solving this mystery lies in its mass and its composition. By analyzing its faint infrared glow, astronomers can estimate its age and temperature, which in turn provides clues to its mass. If it is heavy enough, on the order of 13 times Jupiter's mass or more, it likely formed as a brown dwarf. If it is lighter, and especially if its atmosphere shows chemical signs of having formed within a protoplanetary disk, the case for an exiled planet grows stronger. This lonely wanderer challenges the very definitions we use to categorize the cosmos, forcing us to ask if an object's origin matters more than its current solitary state. This cosmic ruler has a broken calibration. Among the Tadpole's countless stars, one particular variable star pulses with a rhythm that defies the very laws we use to map the universe. Known as a Cepheids variable, this star should be one of astronomy's most trusted tools, a standard candle. The principle is beautifully simple. These stars pulsate with a regular rhythm, growing brighter and dimmer over a set period. Critically, the length of that period is directly tied to the star's true, intrinsic brightness. A Cepheids with a long, slow pulse is a brilliant giant, while one with a short, rapid flicker is inherently dimmer. By measuring its pulse period from Earth, astronomers can determine its true power. Then, by comparing that calculated true brightness to how dim it appears in our sky, they can calculate its distance with remarkable precision. This method has been a cornerstone of cosmic cartography, helping us measure the scale of our own galaxy and beyond. But the Cepheids in the Tadpole is a rebel. Its pulse period and its actual brightness are out of sync. It does not obey the established period-luminosity relationship. If you used its rhythm to estimate its distance, you would get a number that is profoundly wrong, throwing your entire cosmic map into chaos. So what could cause such a fundamental tool to fail? One possibility is that this star is not alone. It could be part of a binary system where two stars orbit a common center of gravity. The light we see would be a blend of both stars, distorting the measurements. The Cepheids' regular pulsations would be superimposed on the constant light of its companion, making it appear either too bright or too dim for its pulse rate and corrupting the data. Another factor could be the star's unique recipe. A star's metallicity, the amount of elements heavier than hydrogen and helium it contains, can affect its internal physics and how it pulsates. The Tadpole Galaxy may have a different chemical history than our own Milky Way, producing stars with unusual metallicities that subtly change the rules of the period-luminosity relationship. Perhaps this anomalous Cepheids is simply at a different stage in its life, evolving off the main sequence in a way that temporarily disrupts its stable pulsations. Its internal structure might be in transition, causing its rhythm to stumble. This single, non-conforming star is a profound reminder that our cosmic rulers are not infallible. They are built on our understanding of nature's laws, and when we find an exception, it is not a failure of the tool, but an invitation to refine our understanding of the universe itself. Magnetic fields of unimaginable power twist space around a solitary star in the Tadpole's spiral arm. This is no ordinary sun, but a magnetic monster, a stellar body whose invisible influence is so intense it can be seen across interstellar distances. We detect its presence not by visible light alone, but by the unique fingerprint of polarization, a twisting of the light waves that indicates they have traveled through a ferociously organized magnetic environment. This star also blazes with intense and unusual X-ray emissions, a telltale sign of its ferocious activity. The engine for this magnetic maelstrom lies deep within the star's heart, in a seething, churning layer of plasma known as the convection zone. Here, heat rises and falls in vast, turbulent currents, and this roiling motion of electrically charged gas acts like a colossal dynamo, amplifying magnetic fields to strengths thousands of times greater than our own sun's. This self-sustaining process creates a field of breathtaking complexity, a tangled web of magnetic force lines that erupt from the star's surface. The effects of this bottled-up power are dramatic and direct. The star's surface is likely marred by colossal star spots, dark regions of cooler gas anchored by magnetic flux tubes. These are not like the sunspots on our sun, which are mere specks in comparison. On this magnetic monster, a single star spot could be large enough to swallow our entire solar system, a permanent, shifting bruise on its luminous face. Furthermore, the star's magnetic field acts as a powerful funnel, seizing control of the stellar wind. Instead of a steady, spherical outflow of particles, the wind is channeled along the magnetic field lines, forced to stream outward from the star's poles at incredible velocities. This creates a focused, hypersonic jet of charged particles that carves through the surrounding interstellar medium. What would it be like to orbit such a star? Your compass would spin uselessly, and auroras would dance perpetually across your sky, while the star itself would flicker and dim as its gigantic spots rotated in and out of view. This magnetic monster is a stark reminder that a star's true power is not always in its light, but in the invisible, titanic forces it commands. A ghost is being unmade within the tadpole's embrace. The evidence is written in faint, arcing rivers of stars that curl against the darkness, streams flowing not from the galaxy itself, but into it. This is the final, slow-motion act of a cosmic consumption, the Tadpole Galaxy cannibalizing a smaller dwarf galaxy. For billions of years, the immense gravity of the larger tadpole has been pulling this unfortunate neighbor apart, stretching its stars into long, luminous filaments that now wrap around the predator like celestial threads. These star streams are the galactic equivalent of breadcrumbs tracing the path of a disintegrating visitor. But the most telling clue is not in their placement, it is in their very essence. When astronomers analyze the light from these stream stars, they find a distinct metallicity signature. Metallicity in astronomy refers to the abundance of elements heavier than hydrogen and helium, forged in the hearts of stars and scattered by supernova explosions. Large, mature galaxies like the Tadpole have had many generations of stars live and die, enriching their gas with these metals. A small, dwarf galaxy, by contrast, is often a pristine relic, with stars that formed early and contain far fewer of these heavy elements. The stars in these streams possess exactly that primitive, metal-poor fingerprint. They are cosmic foreigners, their chemical composition alien to the tadpole's own, more enriched stellar population. This is the definitive proof that we are witnessing the remains of an external system, a distinct island universe that is losing its identity and being woven into the fabric of its captor. The process is a fundamental driver of galactic growth. The tadpole is not just a static picture, it is a dynamic entity growing by devouring its smaller neighbors, a cycle of creation and destruction that has shaped the cosmos since its earliest days. This ghostly meal reveals a universe in constant, slow-motion flux, where even galaxies are not permanent structures, but temporary gatherings of stars destined to merge and change over eons. A faint, high-energy ghost encircles a portion of the tadpole. This is no ordinary nebula of glowing gas, but a colossal bubble of pure gamma radiation, the most energetic form of light in the universe. Its faint, diffuse glow suggests an ancient and titanic release of power, a burst of energy so immense it flooded a vast region of space with these invisible, penetrating photons. The bubble's very existence points to one of two possible cataclysms. It could be the fossilized remnant of a starburst event, a period millions of years ago when a wave of supernova exploded in rapid succession. The combined shock waves from these dying stars would have acted like a colossal piston, inflating a giant cavity in the interstellar medium and accelerating particles to near light speed. When these ultra-fast particles collide with slower-moving gas atoms or are buffeted by magnetic fields, they can emit gamma rays, creating the faint, spherical shell we detect today. The other, more dramatic possibility is that this bubble is the fading echo of a past jet from the galaxy's central black hole. During an active phase, the supermassive black hole may have fired off focused beams of matter and energy from its poles, punching directly through the galactic disk. As this jet plowed into the intergalactic medium far beyond the galaxy, it would have created a massive, expanding lobe of hot gas and high-energy particles, a structure that now cools by radiating in gamma rays. Pinpointing the exact source of these photons is a monumental challenge for astronomers. Gamma rays are notoriously difficult to focus with telescopes. Unlike visible light, which can be bent and directed by lenses and mirrors, these high-energy photons punch straight through most conventional materials. Scientists must use complex, indirect methods to reconstruct their origin, often relying on the precise timing of their detection or statistical analyses of their arrival directions. The faint, spread-out nature of the bubble means its light is like a distant whisper in a roaring cosmic storm, its signal blurred across a vast volume of space. Is this bubble the final sigh of a long-dead stellar generation, or the fading scar from a black hole's ancient outburst? Its diffuse glow holds the answer, a secret written in the most violent language the universe knows. Deep within the gravitational tides of the tadpole, a dead star broadcasts a rhythmic, perfect pulse. This spinning neutron star, or pulsar, is one of nature's most precise clocks, its beam of radio waves sweeping past Earth with metronomic regularity. But astronomers noticed a subtle, repeating hiccup in its signal, a slight wobble betraying the presence of an unseen companion. The gravitational tug of this hidden object causes the pulsar to sway back and forth in its orbit, allowing scientists to calculate the companion's mass. The numbers revealed something astonishingly dense for its size. The leading theory is that we are not looking at a gas giant or a rocky world, but at the exposed crystalline heart of a former star. This is a candidate for a diamond planet core. The story of its creation is one of cosmic alchemy and stellar cannibalism. Imagine a binary star system where one star aged and swelled into a red giant. Its companion, a dense white dwarf, orbited too close. The white dwarf's immense gravity began to strip away the outer layers of the giant, pulling hydrogen and helium onto its own surface. But this theft had a catastrophic consequence. As the white dwarf gorged itself, its mass increased past a critical threshold, around 1.4 times the mass of our Sun. This triggered a runaway thermonuclear explosion, a titanic detonation known as a Type 1, a supernova that should have utterly obliterated both stars. In this specific case, however, the explosion may have been slightly off-center or incomplete. The blast might have ripped away the outer layers of the white dwarf but failed to completely disrupt its core. What remained was an ultra-dense sphere of carbon and oxygen, its atomic structure crushed by the remnant's own immense gravity. Under pressures millions of times greater than those found at the Earth's center, the carbon atoms are thought to have been forced into a rigid, crystalline lattice. The entire world, perhaps the size of Earth but with a substantial fraction of a sun's mass, may have solidified into a single planet-sized diamond. This glittering relic would be a cold, dark gem, reflecting no light, its existence known only by the silent, rhythmic dance it imposes on its dead stellar partner. It is the ultimate cosmic trophy, the fossilized core of a star that survived its own apocalypse. A star in the Tadpole Galaxy flickers in a way that defies all natural rhythm. Its light does not dim with the steady pulse of an orbiting planet or the predictable cycle of a variable star. Instead, it drops in bizarre, irregular steps, plunging into deep, asymmetrical dips before slowly recovering. This strange dimming pattern ignited one of the most provocative ideas in modern astronomy, the tantalizing possibility of a Dyson sphere. This theoretical alien megastructure, a vast swarm of energy-collecting panels encircling the star, could block its light in just these chaotic, non-repeating ways. The allure of a civilization advanced enough to build on such a scale is undeniably powerful. Yet the cosmos is a master of illusion, and the most extraordinary claims demand the most rigorous scrutiny. The scientific search for an answer quickly turned to more natural, if still spectacular, explanations. The leading theory involves a colossal swarm of comets, thousands or even millions of them, on long, eccentric orbits around the star. As these icy bodies pass close, their long, dusty tails could crisscross our line of sight, creating a complex and ever-changing pattern of shadows. Another compelling idea points to the aftermath of a planetary-scale collision. The catastrophic smash-up of two worlds could have pulverized them into a massive, swirling cloud of fine dust and debris. This cloud, uneven and clumpy, would orbit the star in a loose, expanding ring, its denser knots intermittently blocking the starlight in exactly the irregular way we observe. While the thought of a galaxy-spanning civilization captures our imagination, the truth is likely a testament to the sheer, raw chaos of cosmic construction and destruction, a reminder that nature's own workshop can produce phenomena strange enough to mimic the works of gods. Beyond the tadpole's visible stars, silent giants sleep in the darkness, stretching millions of light years into the void, far wider than the galaxy itself, are two immense lobes of radio emission. These are not structures of gas and dust, but colossal bubbles of high-energy particles and magnetic fields, glowing faintly with the whisper of synchrotron radiation. This is the ghost of a past cataclysm, a fossilized echo from a time when the galaxy's heart was a raging quasar. The immense size of these radio lobes tells a story of sustained fury. To inflate bubbles this vast, the central supermassive black hole must have been actively feeding for millions of years, launching jets of matter at near-light speed with unimaginable power. Those jets plowed into the intergalactic medium, piling up material at their edges like cosmic snowplows, creating these immense structures that have persisted long after the engine shut down. Their faintness is the key to their age. The most energetic electrons, those that radiate the brightest, lose their energy fastest. The fact that we see only this diffuse, quiet glow means the most violent particle acceleration ceased eons ago. The lobes have been coasting and cooling for a time span that likely dwarfs the entire history of life on Earth. They are a celestial clock telling us that the tadpole's wild youth, a period of brilliant, quasar-like activity, is a chapter that closed in the very distant past. This quiet giant, with its sleeping radio heart, is a galaxy that has largely settled into a calm maturity, its most dramatic explosions now just fading fossils on a scale almost too large to comprehend. Yet even the most orderly stellar communities can hide dramatic acts of cosmic rebellion. In one of the tadpole's ancient globular clusters, a dense city of stars that should all be the same age, a strange anomaly stands out. A swarm of brilliant blue-white stars burns fiercely against a backdrop of cooler, aging red giants. These are blue stragglers, stellar rebels that appear impossibly young and energetic compared to their ancient neighbors. Their very existence defies the simple rule that stars in a cluster are born together and grow old together. These blue stars are not true newborns, they are ancient stars that have found a way to cheat death and reset their own evolutionary clocks. The secret to their youthful appearance lies in a stellar fountain of youth, fueled by either dramatic collisions or intimate cosmic partnerships. In the crowded core of a globular cluster, stars swing past each other at incredible speeds. Occasionally, two lower mass stars can collide and merge. This violent union creates a single, more massive star by mixing their fuel together. Since more massive stars burn hotter and bluer, this new stellar amalgamation suddenly appears younger and more vigorous than its peers, blazing with a fresh blue intensity. The other common path involves a close binary system, two stars orbiting one another in a tight dance. As one star ages and swells into a red giant, its outer layers can be gravitationally siphoned off by its smaller, denser companion. This transfer of mass onto the smaller star essentially gives it a new supply of hydrogen fuel, reinvigorating it and causing it to swell in mass and heat up, transforming it into a blue straggler. The donor star is left as a stripped-down, faded core, while the recipient shines with stolen brilliance. This stellar swarm is not a group of true youngsters, but a population of cosmic vampires and collision survivors, proving that even in the serene depths of an ancient star cluster, drama and renewal are always possible. Beneath the drama of colliding black holes and runaway stars lies a deeper, more persistent rhythm. The entire Tadpole Galaxy, along with its cosmic neighbors, may be contributing to a faint, constant hum that resonates through the very fabric of space-time itself. This is the theorized gravitational wave background, a low-frequency choir of ripples created not by one cataclysmic event, but by the combined song of countless supermassive black hole binaries, like the one suspected in the tadpole's core. Each of these pairs, locked in their slow-motion dance, generates its own unique gravitational wave signature as they orbit. Alone, the signal from any single binary is far too faint for our current detectors to pick out from the cosmic noise. But when you combine the contributions from every such pair across millions of galaxies, their overlapping waves are predicted to create a persistent, all-pervading hum, a background static to the universe. Detecting this hum is one of the greatest technical challenges in modern astronomy. It requires listening not for a single loud crash, but for a subtle shift in the behavior of nature's most perfect natural clocks, pulsars. Scientists monitor an array of these rapidly spinning neutron stars across our galaxy, watching for incredibly slight correlated changes in the timing of their pulses. A passing gravitational wave from a single merger would create a specific transient pattern in this pulsar timing array. The background hum, however, would manifest as a persistent correlated jitter, a collective stumble in the ticks of these cosmic clocks spread across the sky. This hum is the soundtrack to the universe's largest scale structure, the cumulative vibration from all the massive objects slowly inspiraling toward merger across cosmic time. Hearing it would confirm that the tadpole's hidden binary heart is not a rarity, but part of a vast cosmic orchestra, all playing the same low, fundamental note. A dying star in the Tadpole Galaxy is sculpting its own cosmic tombstone. This is a pre-planetary nebula, a brief and beautiful phase in a star's life that occurs after it has swollen into a red giant but before its core becomes a hot white dwarf. During this fleeting period, the star is actively shedding its outer layers, creating a vast, expanding cloud of its own atmosphere. But this particular nebula is not a perfect sphere or a simple ring. It is a twisted, asymmetrical masterpiece, a celestial vortex frozen in the act of formation. One side of the cloud billows outwards in a vast, faint lobe, while the other appears pinched and constrained, as if an invisible hand is squeezing it. This profound lopsidedness defies the expectation that such an ejection should be a relatively even process. So what force could possibly break this stellar symmetry? The leading suspect is a powerful, organized magnetic field emanating from the dying star's core. As the star convulses and expels its material, this magnetic field can act like an invisible cage, channeling the outflowing gas into focused jets or restraining it in certain directions, much like placing a thumb over a garden hose creates a directed spray. The result is not a gentle bubble but a complex dynamic structure shaped by invisible lines of force. Another compelling possibility involves a hidden partner. The dying star might not be alone. A binary companion, too faint to easily see, could be orbiting close by. As the primary star sheds its layers, the gravity of this companion would whip the ejected gas into a frenzy, pulling and twisting the cloud into a spiraling, lopsided form. The interaction would create a gravitational dance in the gas, a cosmic whirlpool centered on the two stars. This bizarre object is more than just a pretty shape. It is a fossil record of its star's final struggles, a direct visualization of the powerful, hidden forces, both magnetic and gravitational, that guide the death of suns and the birth of new cosmic structures. Drifting in the tadpole's immense shadow is a ghost of a galaxy, a cosmic paradox so faint it almost wasn't there at all. This satellite galaxy is classified as ultra-diffuse, an object that spans thousands of light years yet contains so few stars it appears as little more than a wisp of cosmic fog. If you were to fly through it, the space between its sparse, ancient stars would be so vast that the night sky would appear nearly empty, a stark contrast to the brilliant star clouds of its parent galaxy. How does something so large and tenuous hold itself together against the tidal forces trying to rip it apart? The answer appears to be an overwhelming amount of dark matter. This invisible gravitational glue provides the necessary mass to keep the galaxy intact, creating a deep gravitational well that binds its few stars despite their wide separation. Imagine a city the size of a continent, but with only a handful of houses scattered miles apart. The only way such a sparse settlement could remain a single entity is if it were built upon an impossibly massive, unseen foundation. This galaxy is that concept made real, a place where dark matter isn't just a component, it is the primary structure, with stars as mere accidental ornaments. The alternative theory is just as compelling, suggesting a much more violent origin. Perhaps this fluffy galaxy was once a much more typical dwarf, but a close encounter with the tadpole stripped away the majority of its stars and gas in a process called tidal stripping. What remains is the resilient dark matter core and the few stars that manage to cling on, a galactic skeleton picked clean by a gravitational predator. This faint smudge of light forces a profound question about the universe. Are we looking at a galaxy that never truly formed, a dark matter fortress that failed to build many stars, or are we seeing the stripped clean remains of a galaxy that was devoured? Its quiet existence challenges our very definition of what a galaxy is, proving that some of the universe's most common structures might be its most ghostly. The faint, lingering glow of a kilonova paints the tadpole's tail with the scattered remains of a cosmic cataclysm. This is the echo of two neutron stars, the ultra-dense cores of dead suns, completing a gravitational dance that began millions of years ago. Spiraling inward at a significant fraction of the speed of light, their final collision released more energy in a few seconds than our Sun will emit over its entire 10 billion-year lifetime. The initial flash was a short gamma-ray burst, a directed beam of the most energetic radiation known, which for a brief moment outshone every other star in the observable universe. But the true magic happened in the expanding debris cloud. Within that superheated, neutron-rich maelstrom, atomic nuclei were forged in a frantic frenzy known as rapid neutron capture. Common elements were bombarded with free neutrons, building up atom by atom into the heaviest and most precious substances in the cosmos. It is here, in this single, violent event, that hundreds of Earth masses worth of gold, platinum, and other rare elements were created and then blasted out into space. The wedding ring on your finger, the circuitry in your phone, contains stardust forged in just such a spectacular explosion. The aftermath is not a peaceful scene. At the heart of this expanding cloud of cosmic treasure, the merged object faces its own dramatic fate. If the combined mass was too great, perhaps more than 2.5 times our Sun's mass, it has already collapsed directly into a new black hole, a silent predator born from the ashes of two stellar corpses. If it narrowly avoided that threshold, it may have briefly formed an impossibly heavy, rapidly spinning neutron star, a magnetar with a magnetic field trillions of times stronger than Earth's, only to succumb to its own density and collapse moments later. This kilonova remnant is a fleeting cosmic factory, a place where the universe forges its most precious metals and decides, in an instant, whether to create a new gravitational monster or let a superstar flicker briefly into existence. Even the fabric of space-time might bear the scars of creation. The next object on our list is perhaps the most hypothetical of all, a ghost so theoretical its existence remains unproven, yet its potential signature has been glimpsed in the data surrounding the tadpole. This is a candidate for a cosmic string, a one-dimensional flaw in reality itself, a crack in the cosmos left over from the universe's first, searing moments after the Big Bang. Think of the universe cooling from an unimaginably hot, dense state, much like water freezing into ice. As it underwent this phase transition, the fabric of space-time itself might not have cooled evenly. Defects could have formed, and a cosmic string is the most dramatic of these, an infinitely long, unimaginably thin thread of pure energy, thinner than a proton but with the mass of a mountain range packed into every inch. Its gravitational influence would be bizarre and unique. Because it is a linear defect, it would not lens light like a spherical clump of dark matter. Instead, it would create a very specific kind of distortion, a double image of any galaxy lying directly behind it with no blurring in between, as if space itself had a perfectly straight crack we were looking through. Furthermore, such a string, if it exists and is moving, would leave a distinct imprint on the cosmic microwave background, the faint afterglow of the Big Bang that permeates all of space. It would create a very slight, linear temperature discontinuity, a razor-sharp step where one side of the sky is a tiny fraction of a degree warmer or cooler than the other. Finding such a signature near the tadpole would be a discovery of Nobel Prize-winning magnitude. It would be a direct window into the universe a fraction of a second after it began, a fossil from the very birth of reality, proving that the grandest structures can be built from the most fundamental and fragile of flaws. This profound silence may be the strangest object of all. We have arrived at the final cosmic oddity, a region within the Tadpole Galaxy that presents a perfect blank slate. It is a stellar neighborhood with all the right ingredients for life as we know it, filled with stable, long-lived suns and planets nestled comfortably within their habitable zones. The chemistry is right, the age is right, everything points to the potential for worlds teeming with biology and perhaps even intelligence. Yet when we point our most sensitive instruments toward this ideal pocket of space, we hear nothing but the natural hum of the cosmos. There is no artificial radio chatter, no evidence of massive engineering, no signatures of advanced technology. It is a perfect, unbroken silence. This eerie quiet forces us to confront one of the biggest questions in science, the Fermi paradox. If the universe is so vast and old, with billions of potential homes for life, then where is everybody? The tadpole's silent region offers a chilling potential answer known as the Great Filter Hypothesis. This idea suggests that at some point between the emergence of simple life and the rise of a galaxy-spanning civilization, there exists an obstacle, a barrier so formidable that almost no species can cross it. This filter could lie in our past, a rare fluke that we on Earth somehow managed to survive. Perhaps the jump from single-celled life to complex multicellular organisms is astronomically unlikely. Or the filter could still be ahead of us, a universal cataclysm or a technological trap that every advanced culture eventually triggers, from which there is no return. The silent, ideal worlds of the Tadpole Galaxy could be a graveyard of civilizations that never made it, or a nursery that has yet to awaken. This final object is not a thing you can see or touch, but a profound absence, a void of data that speaks volumes. It holds up a mirror to our own future, asking us if the silence we detect is the natural state of the universe or a warning. From the silent heart of a binary black hole to the glittering echo of a kilonova, the Tadpole Galaxy has revealed itself as a universe in miniature. Each of these 30 cosmic oddities, from the phantom dark matter clumps to the theoretical cracks in space-time, represents a fundamental question about how reality operates. This twisted stream of stars and gas is far more than a pretty picture. It is a living laboratory where the laws of physics are tested under extreme conditions. Here we have witnessed planets where they should not be, stars that refuse to die, and ghostly structures built from nothing but gravity itself. Every discovery peels back a layer, only to reveal a deeper, more compelling mystery underneath. The Tadpole challenges our most basic assumptions, forcing us to rethink how galaxies grow, how stars live and die, and what truly hides in the vast, dark spaces between the light. These are not just 30 strange objects, they are 30 keys, each one potentially unlocking a new understanding of the cosmos. The journey through this peculiar galaxy reminds us that the universe is infinitely stranger and more wonderful than we can often conceive. Now we turn the question over to you. Which of these cosmic anomalies captured your imagination the most? Was it the rogue planet with its diamond heart, the silent region that answers the Fermi paradox, or the invisible dark galaxy that might be more common than our own? Share your thoughts in the comments below, and if you are hungry for more deep space mysteries, be sure to subscribe for our next voyage into the unknown.